pardon me, share my screen and start with showing you announcements for today. We're going to look at more factoring, and then we're going to look at the rational expressions, those algebraic fractions. Homework P5 is due on the 25th. Before we get started, I don't want to be that much of a liar. I think on the first day of class, I promised that I would start every class by saying, before we begin looking at the new stuff, does anybody want to look at anything at all from any of the back homeworks? Does anybody have any questions on any of the homework? And again, as I look at the list of assignments, P5 is due Friday, it's factoring. P6, fractions, is due Monday. The problem set by the end of the day Monday, and the test will be before class Wednesday, so by midnight Monday. Does anybody have any question? And I apologize. When I went through and looked at all of this, I lost the chat. Let me reopen the chat in case anybody without audio has a question. Does anybody want to look at anything from any of the homeworks?
I don't have anything in particular, but the radical and rational exponents I struggle with. Can you go over something from that homework?
Sure. Should we look at, usually the last ones are the hardest. Should we look at one or two of the last ones? Would that work?
Yes.
Huh. Tell you, the hardest thing for me is keeping all of these toolbars straight. What you have to remember with these is no matter what your exponents look like, we're going to use our exponent laws in our order of operations to simplify everything. Always remember your order of operations. Always remember your exponent laws, no matter what those exponents look like. Then what you also have to remember is that if an exponent is negative, it means I'm taking the reciprocal of that. Means I'm making a fraction out of it. If an exponent is a fraction, it means that I will eventually, if need be, rewrite it with a radical, depending on what the directions say. So over here, if I'm looking at that assignment question number 28, I have something like 9x to the negative 2, y to the 4 to the negative 1/2 times x, y to the 1/2. It says integers are fractions for numbers, so we have to simplify the number part. It says use exponential notations. That means we don't have to change it back into a radical. We can leave it as a fractional exponent. But then it says positive exponents only. So anything that was a negative exponent, we're going to have to rewrite somehow with a positive exponent. As I look at this, again, I'm thinking order of operations. Order of operations inside parentheses. Inside both those parentheses, there's no work to be done. After parentheses, exponentiation. So over here, I'm taking this first parentheses and I'm raising it to the negative 1/2 power. If it's all multiplication in there and I'm raising it to the power, what I have to do is I have to take each term and raise it to the power. So that gives me 9 to the negative 1/2, and we'll deal with that in a couple minutes. But over here, do you remember when I raise a power to a power, I multiply exponents? And so when I take negative 2 times negative 1/2, I get positive 1. And here with a y, when I raise a power to a power, I multiply exponents. When I take 2 times negative, when I take 4 times negative 1/2, I get negative 2. Now we're multiplying that by x, y to the 1/2. After exponents, we multiply. When we multiply on a common base, we add the exponents. So x to the first times x to the first gives me x to the second. Then y to the -2 times y to the 1/2. Well, I have to think -2 plus +1/2, and that sum will add to -3/2. And so that gives me y to the -3/2. Now I'm going to pay attention to the part that says positive exponents only. If I have a negative exponent, it means I'm going to have a fraction. Any factor with a positive exponent goes in the numerator. Any factor with a negative exponent, when I make that exponent positive, it goes to the denominator. And then it says, right, use integers or fractions for the numbers. So I have to simplify the number part. And when I look at 9 to the 1/2, if my exponent is a fraction, it means I'm taking a root. The radicand is the 9. The index is 2. The exponent is 1. So that's asking me for the square root of 9, which is 3. And so my final answer is going to be x squared in the top, in the numerator. In the denominator, y to the 1/2 is the square, 9 to the 1/2 is the square root of 9, which is 3. And they tell me to leave that other thing with a fractional exponent, y to the 3/2. And so that would be my final answer. I'm going to tell you, I agree with you. Jumping from this to this, if I tried to do that all at once without the in-between steps, I would find it overwhelming. But using my order of operations, one step at a time, first multiply the exponents, then multiply, add the exponents, then rewrite it as a fraction. I think each individual step's fine. It's overwhelming if you try to do it all at once. But always your rule that you're going to follow is that order of operations. Lauren, is that one any better, hon?
I guess. I mean, can we do another one?
Yeah, we'll do the next one.
Okay.
If you want more practice, realize even if you've got the homework all right, you can go back and do it again and again and again. If you got it all right the first time, the best grade is the one that counts. Redoing a problem will never lower your grade and in the homework. So, keep trying them. Try them over and over and over again until you can get them on your own without that help function. So let's see what we've got here. Here we've got inside the parentheses, what do we have? We have x to the -5/8, y to the 1/2 over x to the -3/8, all being raised to the -8 power. Order of operations, we start inside the parentheses. This time, do you see inside those parentheses, there's work that I can do. I can divide with the x's. And you remember, in order to divide, we subtract exponents. So that's going to be x to the, let's see, numerator is -5/8, and the exponent minus -3/8. Remember, to subtract, we add the opposite. So that gives me -2/8, and that reduces to 1/4. That gives me x to the 1/4. That's the only y there, so I'm going to leave it as y to the 1/2. And so do you see how all I did was simplify what's in the exponents using my division?
Yeah, that one was easier.
We're not done yet, though. Now we have to raise it to the -8th power. Now, when I raise a power to a power, do you remember, to raise a power to a power, we multiply exponents. So 1/4 times -8, well, 1/4 of 8 is 2, so that's -2. Y, 1/2 times -8, well, 1/2 of -8 is -4. And so now we're going to, actually, it doesn't say to write it with only positive exponents, but usually they want you to write it with only positive exponents. Since I've got negative exponents, I'm making the fraction. Anything with a negative exponent, that factor becomes positive. When I move it to that exponent, becomes positive when I move that factor to the denominator. Since there's nothing left in the numerator, we'll put a 1 there. And so this will be our final answer here. And so even if those exponents are fractions or negatives or anything like that, it's the same as any other exponent. If I multiply with a common base, I add the exponents. If I divide with a common base, I subtract the exponents. If I raise something to a power, I multiply the exponents. Rule of thumb, we don't like to leave exponents negative. So if your final answer has a negative exponent, usually you're going to rewrite it with a fraction. And that part with a negative exponent, the exponent becomes positive when we move it to the denominator. Unless it was negative in the denominator, a negative in the denominator would become positive when I move negative exponent, not a negative number, a negative exponent in the denominator will become positive when I move it to the numerator.
When you simplified -2/8, why isn't it -1/4?
It is. It's because I was tired. And so that becomes a positive. And so that goes up to the front. It's because I just lost my sign. Can I blame it on bad vision? It's a careless mistake. And I know that a lot of people really know what they're doing, and their biggest problem is those careless mistakes. They're like all of a sudden losing a sign. And I have to tell you that as much as I keep saying, don't make careless mistakes, be careful, pay attention to details, I'm prone to doing that too sometimes. I'm sorry. Thank you for keeping me honest. Okay. I'm going to clear that. And I'm going to get out of this. Oops, no, I'm not. I'm going to clear that. I'm going to change my finger back into a mouse. I'm going to get out of this assignment. And if everybody's all right, I'm going to try to pick up from where we left off. Where we left off, we were factoring. We were factoring trinomials. We're going to today kind of pick up from where we left off with more factoring. So let's start looking at an example of a trinomial that I don't think we factored last time. Let's look at an example. Let's look at, did we do 6x squared minus 19x plus 10?
No.
Now, and I apologize. Vail, I didn't see your, Olivia, remind me at the end of class to add you. Vail, so make it a little bit bigger. Is this, okay, I know what you're talking about. So I'll change this example. I'll change it so that we've got 19xy plus 10y squared. Val, is that closer to what you were wondering about in the homework? So 6x squared, when I factor, I look at the first. 6x squared can be x times 6x, or it can be 2x times 3x. And then I look at the last. 10y squared can be 1y times 10y, or it can be 2y times 5y. Is everybody all right? I am ignoring that middle term. I look at the factors of the first. I look at the factors of the last. With me so far? Now, what makes some people confused is if you look at it right away, that middle has xy, and you wonder, how can I get the xy? Well, let's think about this. The factors with the x's are going to go in the first. The factors with the y's are going to go in the back. And I just have to worry about where the numbers go. Remember, we had said that if this is a plus sign, it means my signs are the same, and they'll both be minus signs. But even before I fill in the coefficients, do you notice if I FOILed this, first would be x squared, outer would be xy, inner would be xy. And so that's how we get that middle term. Don't look for the middle term until you're checking by foiling. And before we check by foiling, we have to decide which, Dantasia, remind me at the end of class to add you to attendance. When we, before we check by foiling, we have to put in those coefficients. So we have to decide between the 1 and the 6 or the 2 and the 3. And we have to decide between the 1 and the 10 or the 2 and the 5. And when I make that decision, that's where I start playing around with the numbers in my head. Is there any way I can pair 1 and 6 with 1 and 10 to get 19? I don't think so. Is there any way I can pair the 1 and 6 multiplying by the 2 and the 5? Is there any way that'll give me a 19? Well, if I take 6 times 2, that's 12, and 1 times 5, that's 5. 12 and 5 is 17. If I take 6 times 5, it's 30, and it's way out there. So I don't think I'm going to use the 1 and the 6. If I take the 2 and the 3 with the 1 and the 10, well, if I take the 2 times the 10, it's 20, and that's too big. If I take the 3 times the 10, that's 30, so that's too big. So I don't think I'm going to do that. But here, if I take the 2 and the 3 and the 2 and the 5, well, 2 times 2 is 4, 3 times 5 is 15, and that gives me the 19. So it's going to be 2x and 3x, and it's going to be 2y and 5y. And if I put the 5 where it gets multiplied by the 3 in the FOIL, and the 2 where it gets multiplied by 2, I think it's going to work. First gives me 6x squared. Outer gives me minus 4xy. Inner gives me minus 15xy. Last gives me plus 10y squared. And because when we started, we focused on the first and the last, I knew that those would work. And while the xy seemed confusing, do you notice when I FOIL, that does give me the xy? And by carefully placing my numbers, I've got that negative 19 in the middle. Val, any better? All right, so that's general trinomial factoring. In addition to general trinomial factoring, there's a couple of special cases of factoring that we're going to look at today. And the first special case for factoring is a perfect square trinomial. And somebody's got some really fun music in the background, but could you mute it because it's a little distracting? When I look at a perfect square trinomial, I think last class I said there was a pattern that you could memorize but didn't have to. For that pattern, I think we looked at something like a plus b squared, and they said it was a squared plus 2ab plus b squared. And if I had a minus b squared, that gives me a squared minus 2ab plus b squared. And I said, for the most part, if you're multiplying, your life is easiest. Who's playing music? Could you mute, please? Does anybody know where that's coming from? Thank you. And I had said that with these, you're better off multiplying it by itself than memorizing for the most part. But if I'm factoring, it doesn't if you recognize the pattern, you're good as gold. But what I notice is whenever I see